So hello, I'm Warren Davison. I'm going to give a talk here on creative cartography with arcade expressions. So for those of you who don't know, arcade expressions are an ArcGIS Pro and across kind of the ArcGIS suite, but they give you the ability to do all kinds of neat calculations or concatenation of text and all kinds of other crazy things. So this is how I used those expressions to create spike maps. And it kind of originated from a talk amongst our team on the story maps team, where we kind of dive into neat cartography, data visualization examples that are out there in the world. And more often than not, those lead to me going down a rabbit hole, reverse engineering, or finding ways to build those into our workflows. Because spike maps in this case aren't necessarily something that's readily available from the symbology panel in ArcGIS Pro. So this was going to require a combination of symbol effects and arcade expressions for me to actually kind of make them. So I'm going to start with a recorded demo. But basically, to create spike visuals, I started with a point data set. So I've taken Pennsylvania here and basically created a point data set for each of the counties. I'm Canadian, so I assume it's counties. Thank you. And in the symbology pane, basically what I'll use is the symbol effects, which are kind of like a dynamic rendering effect that you can do to your symbology. And I'm going to use this regular polygon effect as a global effect. And what that does is it creates kind of a dynamic polygon around the geometry of my data set. In this case, I'm going to use it to create a three-sided polygon so that we have a spike. And what that does is it lets me fill that regular expression polygon with a fill layer. And you have all kinds of controls about the radius and the number of edges. But if I set 3 edges and a size of 5, that gets me a nice little triangle there. And from there, I'm going to henceforth refer to this as my spike. And I'm going to use what they call a scaling effect. And again, applied as a global symbol, which kind of makes those effects act on the, Craig will correct me, but the highest level of the symbol as opposed to the individual components that make up the symbol. And that will allow me to dynamically scale that symbol effect on the X or Y axis. And if I blow up the scale on the Y, you'll see that I get something that looks like a spike. But what you might also notice is that that scaling acts around the central anchor point of the symbol. So to correct things and compensate for that, I'm going to use a move effect, another symbol effect. And what that can do is self-explanatory. It moves our symbol in space relative to its original, the point of the feature. Again, we get the handy controls for the X and Y direction, so you could use this for all kinds of other creative purposes. But we can actually just use that to move our symbol up or down and side to side. But you'll note that this is all applying across every single point on our map. So not super useful to us at the moment, but that is where arcade expressions come in. And that's in heading down this path of custom symbols, you are going to have to leave the convenience of the proportional symbol dialog behind, and you'll have to lean on some rather shoddy high school math, as I found out. So essentially what to do is, using that scale, we're going to remap the data value to some scale value. And that's a range of values in the data set. So I've got this arcade expression that, if you want to Google it, it's just linear expression or linear scaling equation. And basically that takes the bookends of your data value, your lowest and your highest, and you remap it to bookends of a scale value. So for instance, I want my symbol to be 1 point high when the data value is the lowest, and I want it to be 10 points high when it's the highest. And basically that just takes every data value in your data set, and it will scale each spike proportional to that. Again, that scaling acts around a central point. So it's kind of awkward. And as you note there, I'm pointing out where the spike is centrally anchored over the county, and it should kind of be moved up. So one quick thing is that this is all linear scaling. For some things I'll show you later, there's another scaling method. It's a square root scaling method, and that's due to proportions of area being perceived. Well, I'm not the expert in it, so I'll leave it there. Someone else can explain that. But to dynamically recenter these, I'm going to use basically the exact same equation, but basically whatever I get out of it returned by the arcade expression. So you can, as I should have noted earlier, you can define all kinds of variables. So I've pulled those from the data, and I'm just going to point those at an attribute. And then I've got those symbol parameters handily bookmarked. And then that's kind of the extent. And basically, instead of just taking the output, I'm going to basically cut it in half because the spike is a certain height, and I need to only shift it half the height. And that's how we can apply that to our move effect, which I've glossed over. But using the attribute-driven symbology, you get those kind of database signs, and you can basically bind your symbol effects to some property of the data or an arcade expression, which is where how this was done. But that move effect now aligns our spikes. And now, the nice thing is that this is all dynamic. If I go in and I want to, say, change the size of my maximum spike, then I can just revisit those two variables. Again, talking on that like iterative and finding those efficiencies. If you've got this script, then you can just plug those in, and I can make my spikes larger without having to change any kind of, or too much in terms of my expression. And you can kind of tailor that to suit your needs. So that's the core of creating a spike map. But of course, you can kind of garnish these to your heart's content. I really like adding the stroke around the top edge to kind of define things. And I recently stumbled upon the cut effect. And what you can use that is basically, you can apply a stroke to the entirety of your symbol, but then you can fumble with the symbol panel, as I did, and find out that you can actually cut some number of points of the stroke to kind of open up that bottom of the outline, and it gives you a nice kind of highlight on the top edge. And again, instead of a solid fill, you can get fancy and go and use a gradient fill and orient that so it goes from, as John Nelson would say, fully transparent black to, black to semi-transparent black or fully transparent black or something like that. And then that way, that gradient fill fills your spike. And again, now you can actually see where I've cut the stroke at the bottom, and it kind of gives it a nice effect of actually coming off the map as opposed to just some triangle slapped on the map. And you can go all crazy with that, add shadows, other gradient fills, things like variable colors. So these are, if you have a solid fill, you could bind that to a data variable, so you almost have a bivariate spike where the height is one attribute, and the color coding of the spike is a different attribute, which is what I did with that initial map, which we'll revisit briefly. But and one thing to note on this is that they benefit from the feature order. So you'll notice that it's not too transparent with the gradient, but they can draw over each other in funny, weird ways. So I've basically given these attributes know the x and y points of their coordinates, and you can basically just order them so that they draw based on latitude, and that those with lower latitudes draw atop those with higher latitudes. And that way there's no kind of conflict, and hopefully I pointed that out in the screen recording. But so that's just spike maps. I'm going to give you some stretch goals here where you could apply that same kind of scaling logic of arcade expressions to some other bonkers symbols. So here's Emile Chasson's crazy impressive data visualizations. Despite being Canadian, I do not know much French aside from how to ask for the bathroom. So I'm not going to try and read this, but it's something to do with trains, I believe, and rail networks, I think. You can correct me later. So what I did was basically take those kind of various symbol components, the bars, the pies, the wedges, and I broke it down using that same data set to do with commuting to work from the Living Atlas, and assigned some somewhat coherent variables to each. Basically, you've got cars, people who drive to work on the right in the orange, people who take transit on the left in the green, and I decided to highlight those who drove alone versus those who rode the bus for each of those separate things, and then the bottom kind of semicircle is those who worked from home. And then applying that to our map of, wow, rasterization is something. I applied that, so basically exact same point data set. I've got various different symbol elements, all scaled using that same equation, pointing at different attributes. And we can kind of, yeah, lessons learned, pixels. You can see that there's some slight trends. Obviously, in Philadelphia, where there's a much higher population, that symbol's bigger, and the transit is slightly better, or you see more of it. I hope my next ones aren't as bad. So here's another example. August Chevalier's hachure hillshades completely caused an obsession for me several years back. And I don't have the time to hand shade every slope. So I found a way to automate some of this. There's obviously a Python script to do all this, but basically all I did was infuse slope and aspect properties and bound those to contour lines. So here's a zoom in of that glorious technique. And I use that same arcade expression logic of linear scaling to control things like, basically I took the railroad symbol, the default railroad symbol from ArcGIS Pro, and bound several different attribute values to various properties of the symbol. Those are the weight of the hachure tick, the spacing of that, and also the length, so that varies depending on the type of terrain beneath. And if you were to throw that, and that's one of the samples I generated, but if you were to throw that at that same map, you can recreate it. This was my rendition to see if the effect worked. And then you could also throw that same technique at a slice of the Grand Canyon with, no holds barred, show me everything. So it's kind of a fun way to use those arcade expressions for things that are, outside the box cartography-wise. So there's that map again. And basically in closing, don't be shy about leaving the symbol property panel behind and get creative with some of the arcade expressions to kind of augment your cartography workflows and create something really kind of bespoke. And there's a story map tutorial on how to step-by-step go through everything I just kind of ran through here for reference. And I will share these slides in the Slack channel afterwards. So that's it. Thank you.
We have time for some questions if you're willing to answer. All right, cool. We have our first asker.
Sometimes the centroids align north-south, and so one spike obscures the other. You saw that where Philadelphia obscured Bucks County, where I think San Diego obscured Los Angeles. Any thoughts about solutions?
What you could do is because this actually came up in a work chat recently, is ways to offset symbols like that. When you see those types of things, because of my familiarity with the arcade expressions and this and that, I might suggest just assigning an attribute to that specific feature for an offset, and you could then get fancy and basically say if your manual override attribute is populated, then you could have the arcade expression, compensate by shifting it left and right, or you could just bind the X offset to that manual override property and provide a number of points to shift it. So not the most I guess, dynamic or automated. But yeah, I would just kind of maintain that in a separate attribute, perhaps.
Do we have other questions for Warren? Anybody?
To add on to the last one, that way it wouldn't actually move the point geometry. Your geometry always stays fixed. The arcade never actually moves your actual where your data is. It's just shifting the rendering of the symbol. Sorry, go ahead.
Nope. Just if no one else has any other questions, give it up for Warren.